Today we're going to be talking about simplifying expressions. So in your table of contents, we should have simplifying expressions on page 12. Okay, those are going in on page 12 and 13 because they're two-sided here. So pause if you need to take time to do that. Okay, but when we're talking about simplifying expressions, we're talking about exactly that. How do we get things in simplest form? Okay, and there's one thing that we might have to consider to get something in its simplest form, and that might be that we need to combine like terms. So this is one thing that might happen. Okay, terms with the same variable can be combined. And when we do that, we always use the same sign. Okay, the same sign that we see in front of the variable. So not after, not someplace else. We don't change the sign. We don't do anything like that. We keep that sign the same. So that's one of the biggest mistakes that my students have when they're combining like terms. They get it confused with solving an equation, and they forget that they have to keep that sign the same. Okay, so like terms are the same if they have the same variable, and then we're using the sign that we see in front of it to get them together. So if we look at something like 11a minus 7a, hopefully we all agree, okay, yep, those are definitely like terms because these both have the variable a sitting with it. Okay, then we're looking at the signs in front of them. So especially if you're a big calculator user, right, this is a positive 11 and a negative 7. Okay, and we're keeping the signs just how they are. So you could think about this as a negative or as a subtraction. My students say to me all the time, Mrs. McKinney, is that a negative or is that a subtraction? I mean, they are the same thing. It's just how we read it in context. So if we're going to combine an 11 minus a 7, or an 11 with a negative 7, okay, that's going to leave us with a 4, and then our variable stays the same. Okay, if you're a calculator user, you can use your calculator just like you see it. You can do 11 minus 7, and then just bring that a variable with it. Now, if there's more than one variable happening, then we just need to make sure we collect the ones that have the same variable. So if we look at example 2, we have an n here, and we also have an n there. Okay, so to get those combined, again, we're using the ones in front. So we have a positive 3 minus n. We're using the 1 in front. Now, this n doesn't have a coefficient sitting in front of it. So we know we have a 3n, and we know we have that minus n. But what we need to make sure we're clear of is that if we don't see that coefficient, that number sitting in front of it, that is really a 1. So 3 minus 1 gives us a 2, and that will leave us with a 2n. And then we'll do our m's. So we have a negative 2m plus 11m. So we're doing a negative 2m plus 11m. Okay, a negative 2 plus 11 is a 9, a positive 9m. So because this is 9m and this 9 is positive, it tells us what sign to fill in here. If this is a positive 9, it will be an addition sign, right? Is it addition or is it a positive? They are the same thing. Then this is an n and this is an m, so we can't go any further, so that is our final answer there. So number 3, same idea. Okay, we have some x's that can go together. So we have a negative x plus 7x. So like I said before, if we don't see that number in front, it's really a 1. So we have a negative 1 plus 7, which gives us a 6x. Okay, then we'll move on to our y's. Okay, when we look at the y's, we don't have any other y's. So there's nothing to combine with it. So we just know that this 6y is positive, so we get a positive 6y. Then we have our constants. Constants are numbers that don't have anything variable-wise attached to it. So a negative 1 and a positive 32. Okay, so a negative 1 plus 32 will give us a 31. That's a positive 31, so we'll have plus 31. So our final answer will be 6x plus 6y plus 31. Okay, the second thing that might happen when we are dealing with simplifying expressions, okay, is that we might have to deal with the distributive property. Okay, the distributive property tells us that there are parentheses happening. Okay, so if we're dealing with the distributive property, we're going to see some parentheses happening. And those parentheses are going to tell us to distribute. Okay, but the distributing part is happening through the process of multiplication. So we are going to take the number that is in front of the parentheses, and we're going to multiply it to every term inside of it. So if we look at example one does have parentheses, right? Parentheses tell us to take the number in front of the parentheses, so this 5, and we're going to pass it out to everything inside the parentheses through multiplication. So we want to take that 5 and multiply it times the 4v. And we also want to take the 5 and multiply it times this 13. Now, I think the easiest way to think about this is to keep the sign with it. So to keep this as a negative 13. So 5 times 4 is 20, so that's going to give us a 20v. Okay, then we're going to take 5 times negative 13. 5 times negative 13 gives us a negative 65. So when we write that negative and we put it together, now we read it as subtraction and we get 20v minus 65. Okay, our next one, our number in front is a negative 3, so we're going to pass that out to each one. So if we go to pass that out, a negative 3 times a 4y is going to give us a negative 12y. A negative 3 times a negative 8 is going to give us a positive 24. So we'll get a negative 3y plus 24. Now on example 3, we have 2 sets of parentheses happening. So we almost want to think about this as 2 separate problems. We have this first problem that's happening over here with the 3 and the 5z plus 7. And then we have our second problem that's happening over here with our minus, then 4z minus 11. So if we first start by looking at our 3 times 5z plus 7. Okay, well, if we pass that out, that's going to give us a 15z. Oh, I didn't finish my z, plus 21. And then our second one says this minus in front, and then we have a 4z minus 11. So if we don't see a number sitting there, there's really a 1 there, right? That's really a negative 1. So we're passing out a negative 1. A negative 1 times 4 is going to give us a negative 4z. And a negative 1 times a negative 11 will give us a positive 11. Okay, so now we have this whole thing of 15z plus 21 minus 4z plus 11. That took care of the distributive part. But we don't want to forget the fact that we learned this information up above. And so we want to apply that to this piece as well, where we can combine like terms. So a 15z minus a 4z will give us an 11z. And a 21 plus 11 will give us a 32. And so our final answer will be 11z plus 32. Okay, now I want you to take just a moment and without using a calculator, I want you to try and simplify this entire problem. Now, simplifying that by hand, my students tend to either be successful or the most likely mistake comes up with the idea of what we've learned about order of operations. For the majority of us, as soon as we hear order of operations, we think PEMDAS. Okay, and my students believe that that means parentheses, then exponents, then multiplication, then division, then addition, then subtraction. Okay, but the problem is that's not actually what it means. It's kind of a big error that we're taught to believe. But instead, what it actually says is that multiplication come together and we do them from left to right. Okay, the same thing is true of addition and subtraction. They come together. It is not addition before subtraction. It's do any addition, and whichever one you see first, going left to right, is what you do first. So if we actually look at this example up here, the most likely place that my students make mistakes is, for example, looking at this section right here, or this section right here. Okay, they'll take 2 times 3 and then take the negative 12 and divide it by it. But instead, what we need to be doing is taking the negative 12, dividing it by 2, which gives us a negative 6, and then multiplying it by 3, which gives us a negative 18. Now, I am going to tell you that you do always have access to a calculator. So you could 6 minus 4, type this all in, plus 5. Now these brackets are really telling us to use a parenthesis. They just show up the same in our calculator, so we need to type it twice. 3 minus 2 squared, plus 1, minus 12, divided by 2, times 3 equals, and we get out a final answer of negative 16. The thing is that when variables come into play, we want to make sure we truly understand that addition and subtraction come together, and we are doing that from left to right. Okay, the last thing that we are going to say is down here when we are looking at our substitution, okay, is our actually plugging in values and then simplifying it. So it's telling us if A equals 6 and if B equals 14, what would our solution be? Okay, so that says if we take this 6 and we plug it in, so A is getting replaced by 6. So anywhere we see an A is going away, and 6 is going in its place. Any place we see a B, B is going away, and 14 is going in its place. Now, when we didn't see an operation there, that was a 7A. No operation means multiplication. So this now says 7 times 6 minus 3 times 14. I don't care if you break that up into smaller pieces or if you want to use your calculator to then say, okay, 7 times 6 minus 3 times 14. Doesn't matter to me. We get an answer of 0. We just have to make sure if we're using our calculator, we're using it correctly. So over here where we see an R, our R goes away, our negative 11 goes in its place. Okay, our 5 is going in for our S, so where our S goes away, a 5 is going in its place. So this was a 3 times S, so now this is going to be a 3 times 5. Minus 8, in parentheses, okay, minus negative 11. Again, I don't care if you use a calculator as long as you use it correctly, which means making sure, right, we're getting that parenthesis in here and we're making sure that negative is getting included. And we'll get out an answer of negative 4. Last one. W is getting replaced by 4, and I see that W in 2 places. So this W is becoming a 4, and this W is becoming a 4. This Y is becoming a negative 7, and this Y is becoming a negative 7. Okay, so we have to be really careful here now when we're talking about this. This was multiplication with the W and the Y, so a 4 times a negative 7 is fine. Plus, we are replacing that Y with a negative 7, which means we want negative 7 squared. We have to make sure that negative 7 is going in parentheses. Okay, we don't want to square 7 and then make it negative. We want to square all of negative 7. Then we have a 3 times a 4 minus a 5. Make sure you are using your calculator to help you and not to become a problem. So we talked about this when we were using our calculator. Your best bet is going to be to do the numerator by itself, right? When we have this long sort of fraction bar. So do that numerator first. Okay, I'm just typing that in my calculator and it gave me out an answer of 21. Make sure that parenthesis is going around the -7. Okay, then I'll do the bottom. And then we can worry about dividing. So 21 divided by 7 gives us a final answer of 3.